Hello, welcome to Meep's Math Matters. I'm Meep, and today I'm going to be talking about arithmetic series. We've seen arithmetic series before in previous videos where I was adding up 1 plus 2 plus 3, etc. up to some number n, and when I was adding up the odd numbers or adding up the even numbers, plus 2n, and I could say 2n plus 1. What an arithmetic series is I have a sum like this, and between each consecutive terms, I have the same difference. So I add 2 to get the next term. Okay, so as an example, if I'd said 1 plus 7 plus 13 plus 19, and so on, you can see that I'm building up a series where the difference between consecutive terms is 6. And of course, this difference, all it has to do is remain constant. It doesn't have to be a whole number. It doesn't have to be a positive number. Okay? So I'm going to develop a formula for adding these up, and it's going to be very similar to what we saw before for the special cases I had done earlier. Before we get a general formula, I want to look at a specific series, and we'll look at all the different ways that we can come up with getting this sum. So it's 3 plus 8 plus 13 plus 18, etc. And if you notice, the difference between consecutive terms is 5. 8 minus 3 is 5, 13 minus 8 is 5, etc. I'm going from 3 up to 88. Okay, so let's do the same trick that was done, that Gauss did with adding up the consecutive integers, and do it with this. So what I do is I take my series and I reverse the order. 88 plus 83 plus 78 all the way down to 3, and then I'm going to be adding up the items that are vertical to each other. So 3 plus 88 is 91. 8 plus 83 is 91. 13 plus 78 is 91. 91. 91. 91. 91. And if we let S, if we represent this sum with S, this sum of 91s is 2 times the sum we're interested in. So before we can finish figuring this out, we need to know how many terms are in this series. So let's think about this. Okay, if it were 3 plus 8 plus 13 plus 18. Okay, so there's four terms. How would I figure that out? Well, I need to use the fact that the difference between consecutive terms is 5. And notice that 3 plus 3 fives is 18, and I have one more term. So if I do 18 minus 3, okay, so this is the last minus the first, and then I divide by the difference between consecutive ones, which is 5. I'll call that the difference. Okay, I get 3, so I have to add 1, okay, because you want to count the first. That's to count the first term. So let's do that with the 88 and the 3. So if I do 88 minus 3 divided by 5, that's 17. So I add 1 to get the number of terms, so that's 18 terms. That means I have, let's go back up to the 91s up here, that I've got 18 91s. Okay, so 2 times the sum we're interested in is 18 times 91. So the sum equals 91. Okay, those are the addition, time 18 divided by 2. And the answer for this particular case is 819. Okay? So you see the general technique, I reverse the sum, add the two together, and I get a bunch of 91s. Okay? And there's 18 of them. I have to figure out how many terms are in my series. So it's the number of terms times the first item plus the last item divided by 2. The average of the first and the last item. That's interesting. So let's look at the general case. Let's look at this general arithmetic series, okay? So my first item, my first term is a sub 1. I'm going to add that to a sub 2 plus a sub 3 all the way up to a sub n. So I am telling you right away I have n terms. Now this works only for arithmetic series, and so I'm going to give you a general statement of this. This is a sub k minus a sub k minus 1 equals d. Okay? For all the k's where you can do this, okay? So it's a constant, some constant difference, a constant difference between consecutive terms. So I'm going to come up with a couple different formulas for S. I'm not going to rederive this. So S, this is just like what we did before. We have the first element plus the last element. Divide by 2 and multiply by n. I want to say something about the interpretation of this formula. If you graphed an arithmetic series, or the terms in the arithmetic series, on a number line, you would have these points that were evenly spaced out. Okay? Now, what I'm about to say is true for any series. It doesn't have to be arithmetic. You can look at it as you're going to take the number of points and multiply it by the average value of the points, and you will get, okay, so the average of this one is right here in the middle. Okay, here's the average. Okay, so you could do that for any series, but for an arithmetic series, you don't have to look at any of these interior points because they're evenly spaced out. You only need to take the average of the first and the last point. Okay, so that's one interpretation of this formula. Let me give you another formula. This next formula is a little uglier, but if you look here, okay, if you remember, how did we get the number of terms in the series? I took the last one minus the first one, divide by the difference between consecutive ones, and then I added 1. So that's all this formula is. So there's even more manipulations you can do using the relationship between a sub n, d, and a sub 1. So feel free to come up with your own formulas. Play around with it. Try it out with real series, you know, and again, this could be a nice little party trick. You can challenge someone. Okay, you know, we want to, let's add up all the multiples of 7 that are under 100. You know, a challenge like that, you might be able to do that faster than other people using these principles. As always, you can contact me at marypat.campbell@gmail.com, and remember to spread the math love.